All right, we're going to do this Newton's Law of Cooling question here. So, part A says, show the calculus to get to Newton's Law of Cooling from the following equation right here. This equation says that the rate of time of the, I should introduce things. Capital T is temperature, lowercase t is time. So this is the rate of change of the temperature with respect to time. A is the ambient temperature, so the temperature of something surrounding whatever. We're going to do a problem with an oven here. So this oven was set to 375 degrees. So in that problem, A is going to be 375. And then K is a constant. So we get K times T minus A. This makes some sense because it says that the rate of change of the temperature is proportional, that's the K times, to the difference between the temperature, the ambient temperature, and the temperature of the thing that's changing. The bigger the difference, the faster the apple pie will change. The apple pie's temperature will change. There are multiple forms of this thing that we could deal with, but I like this form because it has less negatives. All right, so we'll do part A first. So I want to start with dt over dt is equal to k times t minus a. It's a separation of variables problem. So I'm going to divide by the parentheses and multiply by the dt. dt over t minus a is equal to k dt like that. I can integrate and integrate. Generally, you want to be careful with negatives and chain rule with this, but since we're integrating with respect to t, not a, there's no negative issue. So that gives me ln absolute value of t minus a is equal to k times t plus a constant. From there, I'm going to e to the on both sides because that gets rid of the ln. They're opposites. That gives me t minus a is equal to e to the k t plus c. And then I'm gonna do two moves at once here. I'm gonna move the a over, so I'm gonna get t equals a plus. Now what I'm gonna do is use some log or some exponent rules that you should be familiar with to separate that out a little bit. So that is the same as e to a constant times e to the kt. Reminder of why we do that: 2 to the 5th times 2 to the 7th is 2 to the 12th because 12 2's are being multiplied. That should make some sense, should be obvious to you. And how do we get that? We added them. So this multiplication is the same as this plus here, and we can reverse that. I had the plus here, it turned to multiplication there. Anyway, from here, I am going to go and I'm going to do some back tagging is what I like to call it. I'm going to say let C equal e to the C1. And I'm just going to change that to a C1 and a C1 and a C1. And that just gives me a nicer looking constant here. So this gives me t equals, and I can do that because e to a constant is still a constant. So I get t, let me go at time t is equal to capital A plus a constant times e to the kt. And that's Newton's law of cooling. So we're done with part A there. I'm gonna just do part B as its own separate video. So hopefully you're good with that. And I will see you in the next one.